EV enthusiasts, beware. The most expensive brick on the block, Tesla shares, are lower ahead of the company's latest developments. Meanwhile, GM has just announced their all-new zero-emission engine that will make both electric and internal combustion vehicles obsolete. This radical new technology is said to be the next revolution in the automotive world, driving us toward a completely eco-friendly future of cars. So, let's not waste any time and check out this groundbreaking innovation as GM's CEO announces a new engine that will change the world. What exactly is this all-new technology? GM has been searching for an alternative to EVs for years now, and their search has led them to the all-new compressed air technology. Compressed air was initially explored in the 19th century, mostly for mine locomotives and trams in European cities, most notably Paris. However, the technology was abandoned in favor of internal combustion engines due to their superior power. In the early 2010s, the French car manufacturer Peugeot saw potential in combining compressed air with internal combustion engines, creating a hybrid technology that retained the eco-friendliness of hybrids without needing a battery. Although these prototypes never moved beyond the testing stage, they sparked interest in the automotive industry, especially GM. Recognizing the potential of compressed air vehicles, GM understood that the technology needed significant development to compete with internal combustion engines and the rise of EVs. As a result, GM began parallel research into compressed air technology alongside their work on EVs and traditional vehicles. How do compressed air vehicles function? Compressed air vehicles function very differently from regular engines and EVs. Instead of a conventional piston-driven engine or an electric motor, compressed air vehicles utilize pneumatic engines, also known as compressed air engines. Mechanically, these engines are similar to internal combustion engines using pistons like petrol-powered ones. However, instead of relying on an explosion for piston motion, pneumatic motors introduce air into a chamber, increasing pressure and pushing the piston outward. The air is then released, and a connected spring pulls the piston back, completing the cycle. Since the overall design closely resembles internal combustion engines, GM saw an opportunity to develop this technology rapidly using existing technical knowledge. What are the benefits of compressed air over EVs and internal combustion vehicles? One of the biggest advantages of compressed air engines is that they are 100% pollution-free. They only use pressurized air, meaning no environmental damage is done while the engine operates. Compressed air technology also outperforms electric vehicles in some aspects. Unlike batteries or electric motors, compressed air engines don't require rare earth materials, making them significantly cheaper and more sustainable. Furthermore, generating electricity for electric vehicles often relies on fossil fuels, reducing their true eco-friendliness. Another key benefit is cost efficiency. Compressed air engines operate under lower pressures than gasoline or diesel engines, reducing the need for heavy-duty materials. This makes them cheaper to manufacture and more environmentally friendly when produced at scale. Additionally, operating costs are virtually unrivaled. Compressed air is far cheaper than fuel or electricity and widely available. These engines are also 100% future-proof, as they do not waste resources. Pressurized air remains structurally unchanged after exiting the chamber. Are there any drawbacks to this technology? Unfortunately, compressed air engines have several major drawbacks that have hindered their widespread adoption. Pressurized air has a very low energy density, meaning these engines are significantly underpowered. The torque output is extremely weak, making them impractical for many real-world applications. These engines must operate at high RPMs, leading to excessive component wear due to their mechanical nature. Lubrication is difficult since they don't use liquid fuels, leading to increased friction and maintenance issues. Most prototype compressed air vehicles have a range of only 140 kilometers or less than 100 miles, requiring frequent refueling. Many prototypes store pressurized air in steel tanks, making them heavy and susceptible to explosions if damaged. How is GM solving these issues? Despite these challenges, GM has been working tirelessly to improve compressed air technology, and they have achieved significant breakthroughs. Increased power. New high-pressure air tanks increase cylinder pressure, bringing performance closer to gasoline engines. Extended range. GM has developed chassis-integrated air reservoirs, using fiber-reinforced thermoplastics to improve safety and reduce weight. Improved safety. Unlike conventional air tanks, these new reservoirs won't explode upon impact, making compressed air vehicles safer. When will this technology be implemented? The answer is complex, but there is a strong possibility that compressed air engines could enter mass production within the next few years. GM has heavily invested in making this technology a reality. The mechanical similarity to combustion engines allows GM to develop these vehicles faster than building EVs from scratch. That said, GM isn't doing this out of pure environmental concern. They recognize that internal combustion engines are on their way out, and they lack dominance in the EV market. By developing compressed air engines, GM hopes to create an entirely new market and position itself as a leader in the next automotive era. The past attempts at compressed air vehicles. This isn't the first time a major manufacturer has attempted to implement compressed air technology. Peugeot, about a decade ago, developed a hybrid compressed air vehicle, combining an internal combustion engine with compressed air storage. This Peugeot 2008 Hybrid Air achieved an astonishing 120 miles per gallon. Yet despite its success, Peugeot abandoned the project, citing a lack of profitability, a reason that seems questionable. Some speculate that big oil companies may have pressured Peugeot into dropping the project, fearing that widespread adoption of compressed air engines could disrupt their profits. This theory gains significant traction when examined alongside the mysterious and tragic case of Stanley Meyer, the American inventor who stunned the world in the 1990s with his bold claims of developing a revolutionary water fuel cell. Meyer stated that his invention could power an automobile using nothing but ordinary water, breaking it down into hydrogen and oxygen through a process he called electrolytic separation, and using the hydrogen as fuel. According to him, this breakthrough could eliminate our dependency on fossil fuels entirely. It was a solution that promised to disrupt the multi-trillion-dollar global oil industry, a prospect that certainly would not have pleased powerful corporate stakeholders. As the story goes, Stanley Meyer began attracting attention from international investors, engineers, and curious scientists. But along with this interest came increasing pressure and, allegedly, intimidation. Meyer reported that oil companies had approached him with lucrative offers to either buy out or suppress his invention, all of which he refused. He insisted that his technology belonged to the people and should be used to benefit humanity, not corporations. The mystery took a darker turn on March 20, 1998. After a business meeting with two Belgian investors at a restaurant, Meyer suddenly ran into the parking lot, clutching his throat and screaming, "They poisoned me!" He collapsed shortly after and died on the scene. His brother, who was with him at the time, confirmed the chilling account. Although the coroner's report claimed that Meyer died of a cerebral aneurysm, the suspicious circumstances surrounding his death led many to believe he was silenced, possibly to protect the interests of powerful energy conglomerates. To make matters even more unsettling, Meyer's prototypes, designs, and the now famous water-powered car reportedly vanished from his garage shortly after his death. No official investigation was conducted into the disappearance of his work, and nothing substantial has surfaced since. This has only fueled speculation that Meyer's death was not only untimely but orchestrated. Whether by corporations fearing the collapse of the oil industry or by other entities threatened by energy independence, the notion remains chilling. While skeptics label Meyer a fraud and his invention pseudoscience, the lack of transparency and the mysterious vanishing of his work make it hard to ignore the possibility that we may never know the full truth. His story remains one of the most intriguing and controversial examples cited by proponents of alternative energy suppression. This historical case should serve as a dire warning to companies like General Motors or any other entity daring to explore disruptive energy technologies. If GM is seriously developing hydrogen combustion or water-powered engines, it must do so with the utmost discretion and security. Otherwise it may face the same fate as Peugeot's shelved hybrid innovation. Or worse, meet a tragic end like Stanley Meyer's water fuel cell. The stakes are not just technological or financial. They could be life and death in a world where innovation often collapses.